Beyond the gas giant Jupiter, in the cold void of space, lies a world unlike any other. A world of fire and brimstone. A moon where volcanoes constantly erupt, where the ground is never still, and where radiation levels are so high that a human would perish in minutes. This is Io, the most volcanically active body in the entire solar system. Temperatures on its surface vary wildly, from freezing cold to searing heat within mere kilometers. Lava flows stretch for hundreds of kilometers, creating a landscape that looks more like a vision of hell than a celestial body. And the intense radiation from Jupiter makes it one of the most dangerous places in our solar system. Io is a world of extremes. But how did it become this way? And what secrets does this fiery moon hold? For centuries, astronomers believed moons were cold, dead worlds. But Io shattered that assumption. It challenges what we know about planetary science, and it may even hold the key to understanding volcanic activity beyond Earth. In this documentary, we will explore the history of Io's discovery and how we learned about its extreme environment, the forces that shape its chaotic, ever-changing surface, the scientific missions that have revealed shocking details about this alien world, and what the future holds for our exploration of the most hellish moon in the solar system. A world of fire, a world of destruction, a world of mystery. Welcome to Io. For thousands of years, Jupiter was seen as nothing more than a bright wanderer in the night sky. But in 1610, one man changed our understanding of the cosmos forever. It was Galileo Galilei, one of the greatest astronomers in history, who first spotted Io and its three companion moons, Europa, Ganymede, and Callisto. Using a simple telescope, Galileo observed four tiny points of light moving around Jupiter, a discovery that shattered the long-held belief that everything in the universe revolved around Earth. His observations proved that Jupiter had its own system of moons, much like a miniature solar system. This discovery was one of the first major pieces of evidence that supported the heliocentric model, the idea that planets orbit the Sun, not Earth. But for centuries, Io remained just a dot in the sky, one of many moons, seemingly unremarkable. No one could have predicted the violent, hellish world that lurked beneath its surface. Keycap won the first close-up views, Voyager's shocking discovery. For over 300 years, astronomers assumed that Io was just a cold, cratered moon, much like our own. That all changed in 1979, when NASA's Voyager 1 spacecraft flew past Jupiter and captured the first close-up images of Io. Scientists expected to see impact craters like those on the Moon and Mars. Instead, they saw something completely unexpected: a smooth, lava-covered surface with giant volcanic plumes erupting into space. One of these volcanoes, Loki Patera, was seen spewing material more than 300 kilometers, 186 miles, above the surface, higher than Earth's atmosphere. NASA scientist Linda Morabito, who first spotted the volcanic plumes, described the discovery as one of the most astonishing moments in the history of planetary exploration. Io wasn't just active, it was the most volcanically active body in the entire solar system. Keycap 2. Why is Io so volcanically active? Scientists quickly realized that Io's hellish landscape wasn't due to ordinary volcanic activity. Something much more extreme was happening beneath its surface. Unlike Earth, where volcanoes are caused by tectonic plate movement, Io's volcanic activity is driven by an invisible war of gravitational forces. Jupiter's immense gravity pulls on Io constantly, distorting its shape. At the same time, Europa and Ganymede, two other large moons, also pull on Io, creating a gravitational tug-of-war. These constant forces cause Io's interior to flex and heat up, melting rock into magma. The result? A never-ending cycle of volcanic eruptions that reshapes Io's surface every few years. Io is locked in a never-ending cosmic battle, its surface constantly destroyed and rebuilt by the forces of the universe. Keycap 3. Modern missions and their findings. Since Voyager's discovery, multiple space missions have returned to study Io. Galileo spacecraft, 1995 to 2003, provided the first long-term study of Io, revealing hundreds of active volcanoes and massive lava lakes. New Horizons, 2007 captured stunning infrared images of Io's hotspots, showing that its magma temperatures can reach 1,700 degrees Celsius, 3,000 degrees Fahrenheit, hotter than any volcano on Earth. Juno, 2016 present continues to observe Io from orbit around Jupiter, mapping how its volcanoes change over time. But Io isn't just dangerous because of its volcanoes. It's also one of the most radiation-filled places in the entire solar system. Keycap for the deadliest place in the solar system? Even if humans could somehow withstand Io's intense heat, there's another problem: Jupiter's radiation belt. Io orbits within one of the strongest radiation zones in the solar system. A human standing on Io's surface without protection would receive a lethal dose of radiation in just a few minutes. NASA estimates that an astronaut on Io would absorb 3,600 rem of radiation per day, the equivalent of 1,000 chest X-rays per hour. Io is a world that seems determined to keep life away. But could there still be something lurking beneath its surface? Summary of the historical background section. Heavy checkmark: Galileo discovered Io in 1610, but its true nature remained unknown for centuries. Heavy checkmark: Voyager 1's flyby in 1979 revealed Io's extreme volcanic activity, an unprecedented discovery. Heavy checkmark: Io's eruptions are caused by Jupiter's immense gravity and tidal heating. Heavy checkmark: Modern missions like Galileo, New Horizons, and Juno continue to study Io. Heavy checkmark: Io is one of the most dangerous places in the solar system, with deadly radiation levels. Io is the most volcanically active place in the solar system. Its entire surface is in a state of constant destruction and renewal. But what exactly makes Io so extreme? And how does this infernal moon compare to the volcanoes of Earth? Keycap: 1. The most volcanic world in the solar system. On Earth, volcanic eruptions are rare events occurring in select locations. But on Io, eruptions are happening all the time, everywhere. Scientists have detected over 400 active volcanoes on Io's surface, some larger than any volcano on Earth. Lava lakes stretch for hundreds of kilometers, with surfaces that constantly rise and fall like boiling water. Volcanic plumes shoot up to 500 kilometers, 300 miles, into space, higher than Earth's atmosphere. The scale of these eruptions is something we have never seen on any other world. Keycap 2: Loki Patera, the largest volcanic feature in the solar system. One of the most famous volcanoes on Io is Loki Patera, an enormous lava lake that is nearly 200 kilometers, 124 miles, wide, larger than some entire countries. Every few years, Loki Patera erupts in massive waves, overturning its entire lava surface. This cycle of eruptions and cooling makes it one of the most predictable volcanoes in the solar system. Some scientists believe Loki Patera's eruptions may be driven by a hidden reservoir of magma beneath the surface. If we ever send a lander to Io, Loki Patera might be the perfect place to study how extreme volcanic worlds operate. Keycap 3: The surface of Io, a landscape of fire and sulfur. Io's surface is completely alien, covered in sulfur-rich plains, frozen lava flows, and volcanic pits. Unlike the rocky, cratered landscapes of the Moon or Mars, Io looks more like a painting made of fire and toxic chemicals. The bright yellow, orange, and red colors come from sulfur and sulfur dioxide deposits, constantly reshaped by volcanic activity. Io's surface temperature varies dramatically. Some areas are freezing cold, while others reach over 1,700 degrees Celsius, 3,000 degrees Fahrenheit near active lava flows. The extreme tidal forces from Jupiter cause the entire surface to rise and fall by up to 100 meters, 328 feet, making it one of the most geologically unstable worlds in the solar system. Io is a world that never rests, constantly shifting, constantly burning. Keycap 4: Could life ever exist on Io? At first glance, Io seems like the last place in the universe where life could exist. The heat, radiation, and lack of water make it an incredibly hostile environment. But some scientists believe that Io's extreme volcanic activity could create underground environments where primitive life might survive. Deep underground, beneath Io's surface, there could be pockets of liquid water trapped by heat from the volcanoes. On Earth, we've discovered extremophiles, organisms that survive in boiling lava vents deep in the ocean. Could similar life exist beneath Io's surface? If there is life, it would have to be unlike anything we've ever seen, capable of surviving intense radiation, extreme heat, and chemical-rich conditions. If life can exist on Io, it could redefine our understanding of biology and survival beyond Earth. Keycap 5: The Radiation Nightmare, Io's deadliest threat. Even if we could build a robotic outpost or lander on Io, there is one major problem: Jupiter's radiation belt. Io is bombarded with deadly levels of radiation, trapped within Jupiter's powerful magnetic field. Any spacecraft that lingers too long risks electronics failure, data corruption, and total shutdown. A human astronaut on Io's surface would receive a lethal dose of radiation in just a few minutes, far deadlier than standing next to an exploded nuclear reactor. Exploring Io won't just require heat-resistant landers. It will require radiation shielding beyond anything we've ever built. Keycap 6: Future missions to Io. What comes next? Despite its extreme conditions, scientists are eager to return to Io. Several future missions could help unlock its secrets. Small Blue Diamond. NASA's Juno mission, ongoing, continues to capture high-resolution images of Io's surface from orbit. Uses infrared sensors to track volcanic activity in real time. Small Blue Diamond, the Io Volcano Observer, proposed mission. A spacecraft designed to orbit Io and take close-up images of its volcanoes. Would study how tidal heating works and whether Io could have underground water pockets. Small Blue Diamond future landers and rovers, 2030s and beyond. Scientists are developing heat-resistant landers that could survive Io's lava fields. A rover could explore Loki Patera and send back the first-ever images from the surface of Io. Despite the risks, Io remains one of the most fascinating targets for space exploration. Summary of the main section. Heavy checkmark: Io has over 400 active volcanoes, making it the most volcanic place in the solar system. Heavy checkmark: Loki Patera is the largest volcanic structure ever discovered. Heavy checkmark: the entire surface is covered in sulfur, constantly reshaped by lava flows. Heavy checkmark: there's a small chance of underground life, if conditions allow. Heavy checkmark: Jupiter's radiation makes Io one of the deadliest places in space. Heavy checkmark: future missions could finally land on Io and reveal its secrets. Despite being one of the most extreme worlds in the solar system, Io remains a target of fascination for scientists. But how are we studying this volcanic moon today? And what future missions could finally unlock its secrets? Keycap 1: NASA's Juno mission, studying Io from afar. Currently, NASA's Juno spacecraft is the closest observer of Io. Although Juno's main mission is to study Jupiter's atmosphere and magnetic field, it has also provided stunning new insights into Io's volcanic activity. Juno's infrared cameras have captured images of hotspots across Io's surface, allowing scientists to track volcanic eruptions in real time. The spacecraft has measured how Io's gravitational pull affects Jupiter's magnetosphere, revealing new details about the moon's internal structure. Juno's latest flybys have detected massive changes in Io's lava lakes, suggesting its surface is far more dynamic than we previously thought. But as advanced as Juno is, it can only observe Io from a distance. To truly understand this hellish world, we need to get much closer. Keycap 2: The challenges of sending a mission to Io. Io is one of the most difficult places to explore in the solar system. Any spacecraft attempting to orbit or land on Io must survive several extreme conditions. Intense radiation. Io orbits within Jupiter's deadly radiation belts, which can fry electronics and disrupt communication. Any probe visiting Io must have advanced radiation shielding to survive for more than a few hours. Extreme heat and cold. Surface temperatures range from minus 150 degrees Celsius minus 238 degrees Fahrenheit to over 1,700 degrees Celsius 3,000 degrees Fahrenheit near lava flows. A lander would need heat-resistant materials, similar to those used in spacecraft re-entry shields. Frequent eruptions. Unlike Mars or the Moon, Io's surface is constantly changing, with new lava flows appearing in days or weeks. Any landing site could quickly be covered in fresh lava or destroyed by an eruption. To successfully explore Io, we will need a new generation of spacecraft capable of withstanding extreme environments. Keycap 3, the Io Volcano Observer, NASA's proposed mission. One of the most ambitious ideas for exploring Io is NASA's Io Volcano Observer, IVO, a spacecraft designed to orbit Io and study its volcanoes up close. Unlike Juno, IVO would specifically target Io, taking high-resolution images of its surface. It would use infrared sensors to measure how lava flows change over time. It could detect underground magma movements, helping scientists understand Io's volcanic plumbing system. The mission would also investigate how Io's gravity interacts with Jupiter's magnetosphere, influencing space weather. If funded, IVO could launch in the 2030s, finally giving us a long-term look at Io's chaotic world. Keycap 4, future landers and rovers. Can we touch down on Io? While orbiting Io would be a huge achievement, the real challenge is landing on its surface. Heat-resistant landers could be designed to survive the extreme temperatures near lava flows. Hardened electronics would be needed to resist Jupiter's intense radiation. Autonomous rovers could move quickly across the surface, avoiding lava eruptions and mapping Io's landscape. Some scientists suggest that a future Io mission could use aerial drones, flying above the surface rather than driving over it. Drones could hover over active volcanoes, collecting real-time data without being destroyed by lava. They could recharge using solar panels, operating for weeks or months. If successful, an Io lander could answer some of the biggest questions about this volcanic world, questions that have puzzled scientists for decades. Keycap 5, what studying Io can teach us about other planets. Io is more than just an extreme moon. It is also a laboratory for understanding volcanism across the universe. Studying Io can help us understand early Earth, when our planet was covered in violent volcanic activity billions of years ago. Io's heat-driven geology might offer clues about distant exoplanets, where tidal forces could create similar volcanic worlds. Learning how Io's atmosphere interacts with space radiation could help future astronauts survive on other planetary bodies. By unlocking the secrets of Io, we may learn more about the birth of planets, and even the future of Earth itself. Summary of the present and future of Io research. Heavy checkmark. NASA's Juno mission is currently observing Io, tracking its volcanic activity from afar. Heavy checkmark. Io's extreme environment makes exploration incredibly difficult, but not impossible. Heavy checkmark. The proposed Io Volcano Observer mission could map Io's surface and reveal its hidden magma layers. Heavy checkmark. Future landers and drones might one day explore Io's surface up close, if we can solve the technical challenges. Heavy checkmark. Studying Io could help us understand volcanic activity across the solar system and beyond. Io is more than just a moon. It is a testament to the extreme and unpredictable nature of the universe. A place where fire meets ice, where gravity bends and breaks the very surface of a world, and where planetary forces collide in ways we are only beginning to understand. For centuries, Io was just a tiny dot in the sky, one of many moons orbiting the giant Jupiter. But today, we know it as the most extreme volcanic world in the solar system. It has changed our understanding of planetary geology, showing us that worlds beyond Earth can be more active and chaotic than we ever imagined. It has challenged space exploration, proving that if we can land on Io, we can conquer some of the harshest environments in the universe. And it may hold secrets about exoplanets, helping us identify other volcanic worlds beyond our solar system. Io is a reminder that the universe is full of wonders, and sometimes those wonders are terrifying. Final thoughts. As we look to the future, humanity's journey into space is only just beginning. With new technology and bold missions, we may one day send landers, rovers, or even astronauts to explore the most dangerous moon of Jupiter up close. But until then, Io will continue to erupt, reshaping itself again and again, waiting for the day when we finally arrive to witness its firestorm firsthand.